Hello everyone. Okay, this is the review of Test 1 from Spring 2016 in the Macroeconomic Principles class. So, let's get started. This is your first page, and on the first page you were given a simple supply and demand equation, and then you were asked to solve. You can see the answers there, which you're welcome to copy down. There were 3 points each, but I thought I might go ahead and work them. So the equilibrium price is defined to be the price where quantity demanded equals quantity supplied. The second step is just to copy down what those things are. So the part I have written here doesn't represent any algebraic work yet at all. Now the algebra begins. I'm going to add 150 to both sides. So 850 plus 150 is 1,000 minus 0.5p equals 2p. Now I'm going to add a half a p to both sides, and I get 1,000 is equal to 2.5p. Now I'm going to divide through by 2.5, and I get the equilibrium price is 400. So that's that number right there. And then the equilibrium quantity, for those of you who don't remember, the equilibrium quantity is defined to be the quantity demanded or the quantity supplied at the equilibrium price. So I used the quantity supplied equation just because it was easier. So then it would be 2 times 400, since that was the equilibrium price, minus 150, So 2 times 400 is 800, and 800 minus 150 would be 650, and that's what we have there. So then it asks, given the equations, how much would people want if the government provided this product for free? So what you need to do is draw the demand curve. And remember that this equation is QD is equal to 850 minus 0.5p. And the question is, how much do they want if the government provides the product for free? So it's on the demand curve. If the price is free, that would be down here. And we just want to know what that number is. And you can read it from the demand equation very easily. If the price is set to 0, the quantity demanded will be 850. So then the next question says, well, given the equations, how high could the price go before consumers finally just said that's it, and they just walk away and they don't buy anything? So again, it's on the demand curve, but now we're looking for a high price. So we let the price rise higher and higher and higher. As we do, quantity demanded is falling. Can you see that? Quantity demanded be falling. And finally, they would walk away and not buy anything when you got up to there. And the way you figure that is, that's a place where the quantity demanded is 0, and we're solving for the price. So you would just set it 0 equals 850 minus 0.5p. Adding a half a p to both sides, we get 0.5p equals 850. Dividing through by 0.5, we would get, I don't remember that number, 1,700. So this number is 1,700 right here. So I thought all those were kind of easy, but I thought this one was hard. Given the equations, how high must the price go before producers decide to enter the market? So this question is about the supply equation. The supply equation looks like this. Quantity supplied is equal to 2p minus 150. So now, of course, when the price is 0, they won't make any. When the price is 1 cent, they won't make any. At $1, they won't make any. But sooner or later, they will come into the market when we get right there. So the way you find that place is you set the quantity supplied equal to 0, and you just solve for the price that would go with that. So adding 150 to both sides, and then dividing through by 2, I get a price of 75. Then it says, suppose the government set a price ceiling at 350. Well, recall that this number right here was 400, wasn't it? The equilibrium price was 400. And so 350 would be down here somewhere. So it's going to be binding because it's a price ceiling, right? The price wants to go here. This is the natural order of affairs there. It can't because there's a law, so it's binding. So this would be the quantity supplied, and this would be the quantity demanded over here. And the difference between them in this case would be a shortage. And we can figure out what those things are. It turns out that if you put 350 into the supply equation, you get 550 for this number. And if you put 350 into the demand equation, you get 675 for this number. and then the shortage is the difference between them, which is 125. I've marked here where these answers can be found in the book. Are public parks public goods? No, they're not. They're not public goods because a public good is something that's non-excludable. What is cost-benefit analysis? Well, it's where you sum up all the cost and all the benefits and you see which is greater to decide whether a project is worthwhile or not. What is the tragedy of the commons? That's on page 228, and it lists two of them. That is that one of the tragedies is that no one is motivated to take care of the resource since no one owns it. And the other tragedy is that it will get overutilized. Pigouvian tax is something that we discussed in class. It's not in the book, but it's a tax equal to the negative externality, and it's a way to internalize the externality. So then in number 5 was a discussion that we had in class about free goods, and I argued in class that free goods are really impossible to see, and now I'm asking you why. What could that argument be? And the argument I made was that a good is defined to be something that when you consume it brings you utility, that is, makes you happy, right? Brings you utility. But a free good would be one that when no one has to pay for it, so you would consume it all the way down to its value is 0, because remember, value is always calculated at the margin. So if a good was truly free, you wouldn't recognize it as having any utility because it would just be available and you would consume it all the way down to its last use, had no value at all. Then deadweight loss is a kind of a colorful term we have in economics that refers to a lost efficiency in economics due to a market failure or to a tax, and it's found on page 191. Roman numeral 3 is we've spent some time discussing the difference between concepts of shortage and scarcity. For example, diamonds are scarce, but human blood is relatively abundant. So then, first I ask you, what is the technical definition of shortage and scarcity? So a shortage is a market disequilibrium. A shortage can occur anywhere. It can occur in something that's very scarce, or it can occur in something that's really abundant. For example, water is very, very abundant, but there are some places where we have shortages of water because there's a market disequilibrium. Now, scarcity, on the other hand, is something that comes from nature. It's a fact of life. Some things are just scarce, and there's nothing we can do about it. Diamonds are scarce, gold is scarce, and so forth. Okay, so then in the second one I ask why there is never a shortage of diamonds, but several times a year there's a critical shortage of blood. And then I try to help you. The answer is not because we need blood while diamonds are a luxury. We need many things that do not experience periodic shortages. The graph is needed. So in the case of scarcity, all that's really happening is the supply curve is very, very high or very shifted back to the left, so there's a very high price, but there is market equilibrium. The quantity demanded does equal the quantity supplied for diamonds at some very high price. In the case of blood, I ask in this case, the case of blood, the price of blood is 0. The supply curve I've drawn here is not quite right. I should have drawn it a little steeper like this because some people voluntarily donate their blood even at a 0 price. So there is some quantity supplied, but the quantity demanded always exceeds it. And then, of course, this is a shortage of blood. Then in number 3, this is a kind of a technical question. It just says, let x and y be substitutes and let x and z be complements. Show what would happen in each market if the supply curve of x shifts left. So here's good x. So I've shifted the supply curve of x to the left. That's all you have to show. And the price of good x goes up. Now remember, good y was a substitute. This is something that you could use instead of good x. So if good x gets more expensive, people will buy more of good y. So the demand curve for good y would shift out to the right, and that would also drive up its price. Now good z was a complement. This is something that you would use with good x. And if you notice, in the case of good x, people are buying less x than before. See that? And so since they're buying less x, they would need less z since it's complementary. If this is hot dogs, for example, and the price of hot dogs went up for some reason, people bought less hot dogs, then the demand curve for hot dog buns would shift back to the left. Each one is worth 8/10 of a point rounded up in your favor. So if you missed 1, you would have got a -0. If you missed 2, you would have -1. If you missed 3, you would have -2, and so forth. So you can check my work, but each one of these little squares is worth 8/10 of a point rounded up in your favor. So here we go. A winter crop of Florida oranges has arrived. You can always buy oranges in the grocery store any time of the year, but now oranges are very plentiful. What happens in the market for oranges? Well, the supply curve would shift out to the right, and oranges would get cheaper. So your answers would be the demand curve stays the same, because people don't really pay attention to, they don't say, well, I don't know how many oranges I want because I don't know if it's winter or summer. But the supply curve shifts out to the right. The quantity demanded and quantity supplied both increase, see it, from here to here, and the price falls. And then in number 2, have you ever seen these boxes in the grocery store that have everything you need to make Orange Julius? What happens in the market for this product given conditions in number 1? Okay, so this box of all the ingredients to make an Orange Julius would be a complement to oranges, and since oranges are cheaper and people buying lots more oranges, the demand curve for Orange Juliuses would increase, and so the answers would be increase, supply curve stayed the same, the quantity demanded and quantity supplied both increase, can you see that right there, and the price of these boxes should go up. Then number 3 says, what happens in the market for other types of fruit in the grocery store that compete with oranges? So things that would be substitutes for oranges, if oranges get cheaper and people buy more oranges, then they would buy less of these other things, whatever they are. So the demand curve would decrease, and the supply curve would stay the same. The quantity demanded and the quantity supplied would both decrease, can you see that? And the price would decrease. And then number 4 says, suppose orange growers lobbied the government to prevent the importation of oranges from Mexico. You might think I make that up, but no, this kind of thing happens all the time. What would happen in the market for oranges sold in the United States? Well, for oranges sold in the United States, if we don't import any from Mexico, the supply curve would shift back to the left. The demand curve for oranges would stay the same, but the quantity demanded and the quantity supplied would both decrease, and the price of oranges would be higher. Alright, then number 5 says, okay, given conditions in number 4, right, that we're not going to get oranges from Mexico anymore, what would happen in the market for oranges grown in Florida and California? Okay, so in this case, we're thinking about California oranges and Florida oranges as a substitute for Mexican oranges, and so the demand curve for California oranges and Florida oranges would increase. In fact, that's why they lobby for it. I think it's disgusting, but that's what they do. And then the supply curve of California oranges and Florida oranges would stay the same. Quantity demanded and quantity supplied both increase, and the price rises. It's easy to get these two mixed up because this one over here, number 4, is about the market for all oranges, right, sold in the United States, and this one over here is the market for Florida and California oranges. Roman numeral 5 says the following article appeared in the Post-Courier a couple years ago. I saved it. Use this article to illustrate what has happened in the market for human organs over the last 25 years. Be careful where you mark the price. Well, in case you don't know, it's illegal to sell your organs, but there's a demand curve for them, as this thing shows. In fact, as medical technology has risen, the demand curve of these organs has risen dramatically. It says right here, 18,000 people were waiting for transplants in 1989. More than 76,000 fill the waiting list today. So what's happened is that the supply curve has stayed the same, but the demand curve for these organs has increased. It's illegal to sell them, so the quantity supplied is here. And this used to be the quantity demanded, but now the quantity demanded is much higher. It says in here somewhere about how many people are dying waiting, so this is not just a esoteric example for an econ class. This is real life and death stuff for some people. Alright, the second one says, imagine what would happen in the market for human organs if the medical community were allowed to offer incentives to just sign a donor card. I don't mean incentives for people to go out and have their kidneys ripped out of their bodies. I just mean, like, if you could get money for signing a donor card and people across the country could do that, how would this market be different? Well, what would happen is a lot of people would sign those donor cards, and so the supply curve for organs would rise as some of those people, it's kind of sad, but some of those people would meet untimely deaths and their organs would be available where now they're not. So the supply curve would shift to the right, demand curve would stay the same, and the shortage would be less. And then the last one says, okay, now imagine that there's some kind of medical breakthrough that allows for inexpensive culturing and growing of human organs in laboratories. So now this is a substitute for human organ transplants, right? We're going to grow them in a lab somehow. Under these conditions, what would happen? So in this case, the demand curve for the human organs would fall back to the left as there is now a viable substitute. So I'm not going to work it out again for you, but to begin with, you just set the quantity demanded equal to the quantity supplied. You should get 225. And then when you use that number to calculate the equilibrium quantity, you should get 1150. Now let's impose the tax. So if you notice, you have two supply equations, one without the tax and one with the tax. When you draw them out, they look like this. So the original equilibrium price was 225, and when you use the supply curve with the tax and you set it equal to the demand curve, just like you did before, you set QD equal to QS tax now, you get this new price of 234, so that's the price consumers pay. Now you have to calculate what the new equilibrium quantity is, even though I don't ask for it. The new equilibrium quantity is 1132, and you find it just like you found the original equilibrium quantity. Now in my opinion, the only question on this page that's really difficult is this one right here, the price producers get. It's easy to see visually because this is the price consumers pay. Here's the equilibrium where it came from. This distance right here is the tax. So visually you just come over from there and that would be the price producers get, because this distance from here to here is how much money the government collected for each unit that's sold. But finding this place is kind of hard, and the way you do it is you take this 1132, which was the equilibrium quantity, and you stick it in the original supply curve, because you're really looking for the coordinates that go with this point right here. So if you stick 1132 right in there and solve this thing for P, you will find that the new price that producers get is 222. Then it's easy to figure out what the unit tax was. It's just a difference in those two numbers, and that difference turns out to be 12. That's this thing right here. The tax per unit turns out to be $12, and the tax revenue generated would then be $12 times the number of units sold. And everyone needs to see that this is the number of units that will be sold, not this. This is the original equilibrium, and after we put the tax on, the price will be higher and people will buy less. So 12 times 1132 should equal 13,584. Finally, it asks, imagine that the tax were to double. So instead of $12, imagine the tax went to $24. Would the tax revenue generated also double? And the answer is no, it wouldn't, because if the tax rose from $12 to $24, this supply curve would be way up here somewhere, all right, where this distance right here now would be $24. And even though the government would get twice the money, $24 instead of $12, the government would get twice the money on every unit sold. I hope everyone can see that the number of units that get sold will be much less than before. So no, the amount of money collected will not double. Alright, Roman numeral 7. This one was on a lot of old tests. In fact, I think you asked me about this one last class. There are 5 things that affect the production possibilities curve. 4 of them we call the factors of production. They are land, labor, capital, and entrepreneurial ability. And then the other thing that's not called a factor of production but also matters is technology. So you got 2 points for each of those things if you could just list them. Then I ask you to calculate the production possibilities curve that comes from this data. So the way you do it is you look, okay, when the economic score is 100, the history score is only 40. So this is economics on this axis, so here's 100, and that's 40, so this is this point. And then when the economic score is 96, the history score is 60. So here's 60 for history, and this is almost 100, but not quite, that's 96. And you just keep plotting these points like that. Then you answer these questions. Use the data and graph above to plot the production possibilities curve for this student. Okay, we did that. Does the production possibilities curve exhibit the law of increasing cost, or the law of increasing relative cost? Yes, it does, because it's curved down. It's concave to the origin. Concave to the origin. It's not a linear function. It gets steeper and steeper and steeper as you move. Then we ask, if the student wishes to move from a grade of 76 to a grade of 96 in economics, you can see it in the graph, but it's a little easier to see in the table. If they want to move from 76 to 96, they can certainly do it, but to do it means that their history score is going to fall from 88 down to 60. So the cost of moving your grade from 76 to 96 in economics is the loss that you have over here, and I think I worked it out. It's a loss of 28 points. Then finally, illustrate on the graph the impact of discovering a friend who can help the student study history. So you find a friend that can help you with history, so suddenly the hours that you spend studying history are going to be more productive than before, but it's not going to help with economics. So this extreme point in economics won't be any different, but the extreme point in history will be way out there someplace. So the production possibilities curve shifts out in this kind of weird way, where this point stays the same, but it goes kind of like that. You know, you can't make 120, but that's sort of how it would be. Something like that. Okay, that's the whole test. Here I am again. So I hope you found this test review helpful. I'm sorry we're not going over it in class, but some of these questions will probably show up again on the final exam. So make sure that you understand how to get all of the answers on this test. All right, good luck.